Today, we're going to be talking about Death Valley. You see it here on the screen. And you're probably thinking, why are we talking about Death Valley? Well, that's because we're going to talk about the flat valley effect or flat valley indeterminacy. This is Module 6 in my discussion about the holistic adjustment technique. And I'm using this as an analogy for what happens if you try to solve the type of problems that we have with a deterministic framework and mindset. So if you'll recall last time, I framed this uncomfortable reality, and we're dealing with small data sets. They're high variability. The variables are interconnected, and also each variable represents human behavior, which itself is never fully rational or reasoned or conscious. And so that creates some difficulties in really pulling apart and analyzing that type of data set from within itself alone. So I've set up this problem like, well, you can't solve it within itself and you can't solve it from without. So what do we do? And so let's talk about what do we do if we're trying to solve this deterministically from within its own system. And you might think of an example of that would be applying multiple regression. If you've ever run multiple regression, you've probably seen the coefficient outputs of that regression model seem like nonsense. You know, those coefficients, they function like adjustments within the model, and they don't seem to make any sense as to what you would anticipate. And even worse, whenever you change the data set a little bit or change the way you're defining the variables a little bit, those coefficients may shift dramatically, maybe even changing directions. And so that those differences, they're not random. They're a symptom of what I call the flat valley effect or flat valley indeterminacy. So regression works because it's trying to minimize error. But in the kinds of systems that we just talked about, there are many near equivalent solutions. So, and that's why this image here is a great example, because the regression model is trying to pick a low spot in the flat valley. And so if we want to use this Death Valley as an analogy, let's say I came to you and I said, hey, I want you to meet me at the lowest point in North America. And you'd say, okay, I may have to look that up and say, oh, okay, I'm going to go to Death Valley National Park. And okay, I will see you there. And then you're going to head to probably this exact spot. This is Badwater Basin, and it's 282 feet below sea level. And it is nearly identically flat throughout 200 square miles. So you have a huge area. So if you walk out onto the salt flat here looking for me, chances of you finding me are pretty low because this way that I've given to find me isn't really terribly specific. So, and that's what happens when we apply multiple regression to this type of problem. And there's actually another element to that, and that's when you select a model, a deterministic model, it's almost like you're creating a divot in the desert somewhere. Oh, okay, here's the low spot. Well, yeah, because you've defined this particular model as the way to solve it. And so what you're wanting to notice is that this new low point from any different type of model or slightly different ways of framing your data, it doesn't really tell us anything about the valley. And it certainly doesn't really give you a really good sense of where I am. Are you going to find me in this spot? Am I even close? You don't really have enough information to answer those questions. And so then there's the the extra complication. If you finding me is equivalent to, okay, finding market value. If I'm market value, I'm not standing still. I'm walking around aimlessly within some sort of area. And then over time, the area that I'm walking around in is moving. So essentially, what we're trying to do by using regression or iterative models um, we're telling them to answer essentially the wrong question. They don't fail in this application because the math fails. They're failing because we're expecting them to pinpoint a moving target inside of this flat valley. And so if we were to do that, and what we're essentially trying to do is treat those coefficients within the model as if they were market adjustments, it's not going to work. So that's where it brings us to the holistic adjustment technique. What would happen if we stopped focusing only on a single solution, and instead I want to understand the properties where the solution may exist. So what are the properties of the region? Can I start to define the region where market value may exist and then learn to explore that?